Okay, so if you would have your packet out and you would look at the definition of an undefined fraction, and if you notice it says an undefined fraction has a denominator that's equal to 0. So we're going to follow along in the packet, so everybody should have number 1 out, and you're going to take notes in your packet. So number 1 is right here, and if you look at the first step, it says to set the denominator equal to 0, and we just completely ignore the numerator. So what we're going to do is we're going to take that denominator, and we're going to set it equal to 0, because a fraction's undefined when the denominator is equal to 0. So we're going to start by factoring. I see that I have dots, so I'm going to do x minus 3 and x plus 3. Set that equal to 0. Do my t-chart, and take each factor, and we're going to set that equal to 0. Okay, on the left we're going to add 3 to both sides, and we will get a value of x equals 3. On the right side, I'm going to subtract 3 from both sides, and I will get a value of x equals negative 3. So these two values, when I plug them back into the denominator, both of those values will make that fraction undefined. All right, so let's look at the second one. So again, you are taking notes in your packet. So if we go back to step 1, again it says set the denominator equal to 0 and ignore the numerator. So we're going to completely ignore that numerator, and we're just going to look at the denominator and set that equal to 0. Now I notice that I have a GCF of 2 and x. So I'm going to take that out, and that's going to leave me with x squared plus 2x minus 24. Okay, I'm going to set that equal to 0. So I'm going to keep going because I know I have a trinomial and then I can factor that. So I'm looking for two numbers that will add to positive 2 and multiply to negative 24. So that's going to give me a positive 6 and a negative 4. All right, so now I'm going to solve. So I'm just going to do my t-chart just like I did in number 1. I'm going to take, I have 3 factors now, so I'm going to take each of those and set them equal to 0. Okay, so my first factor, I'm just going to divide everything by 2 to get x by itself. Here, in the second one, I'm going to subtract 6 to get x by itself. Oops, and I made a mistake here. This should be x minus 4, sorry, equals 0. So I'm going to add 4 to both sides to get x by itself. So in this case, I have 3 values of x, all 3 of them, if I were to plug them, obviously one at a time, back into the denominator. These 3 values will make the denominator equal to 0, which makes the fraction undefined. All right, so now we're going to move on to simplifying fractions. So if you would turn the page, and we're going to look at number 4. Now, simplifying a fraction is similar to like if you had, I'm just going to put this off to the side. Think of it in very basic terms, of course, that if I had 2 over 6, right, if I was to reduce that fraction, I would divide both the numerator and the denominator by a factor of 2, and I would get 1/3. So that's essentially what we're going to be doing over here. But obviously, this one's a little bit more complex. So what we're going to start by doing is I'm going to make a blank fraction, and I'm going to factor the numerator. I see that that's dots, so that's going to be 2m minus 3 and 2m plus 3. Now, this denominator is a little bit trickier, so I see that I'm going to have to do rainbow here. So I want to figure out what multiplies to negative 6 and will add to a positive 1. Okay? So that's going to give me 2m squared plus 3m minus 2m. So make that look like a minus. And then minus 3. And then let's group. So I see my first grouping has a common factor of m. So if I take that out, I get 2m plus 3. And my second grouping has a common factor of negative 1. And if I take that out, I also get 2m plus 3. So then that denominator factors to m minus 1 times 2m plus 3. So I'm going to transfer that over to my fraction over here on the left. So m minus 1 times 2m plus 3. So all I did was I factored the numerator, the original numerator of the original fraction in number 4, and I factored the denominator. And what that does is it just allows us to see the numerator and denominator in a different way. And then what I notice is that I have some common factors here. So if I look, I say, oh, well, wait a minute. I have a 2m plus 3, and I have a 2m plus 3. Those are common factors. I can cancel those out. Kind of like if you look over here on the top right-hand corner of the screen, I have two common factors here. I had a common factor of 2, which gave me a 1, and a common factor of 2 in the bottom, which gave me that 3. So it's the same concept, okay? All right, so then let's go back, and if we look and we see what we have left over, we have 2m minus 3 in the numerator and m minus 1 in the denominator. Now, the only way you can cancel anything in the numerator and the denominator is if they are exactly the same, okay? So you can't cancel anything unless you have them being exactly the same. So sometimes kids are a little tempted to take this m and this m and cancel them out. You can't do that because this 2m minus 3 here is a binomial, and this m minus 1 here is also a binomial. So the only way you can cancel a binomial with a binomial is if they're the same exact thing, just kind of like we had right here, okay? So since 2m minus 3 and m minus 1 are not the same, then we cannot cancel them out, and that's our final answer. All right, so the last one, we're going to look at number 6. So again, you should be taking notes in your packet. Now, with number 6, again, we're going to simplify, so we need to factor the numerator and the denominator, and then we're going to try to cancel out any like terms. We're going to factor the numerator and the denominator separately. So let's do this. I'm just going to draw a line here so that we can kind of separate some things. So let's start with the numerator first. So I have 4x to the 4th minus 6x cubed minus 10x squared. All right. So I see with this that there's a common factor of 2x squared. So if I take that out, that leaves me with 2x squared minus 3x minus 5. All right, so I'm going to do rainbow here. So I'm trying to figure out what multiplies to negative 10, that's a negative there, and adds to negative 3. It's going to bring down that 2x squared. Okay. I'm going to bring down, remember, when we do rainbow, we bring down the first term, and we bring down the last term. And now I'm figuring out what multiplies to negative 10 and adds to negative 3. Well, that would be a negative 5x and a positive 2x. Okay. Group the first two, group the second two. All right, let's bring down that 2x squared again. Now, in the first two terms, I'm going to take out an x, and that'll give me 2x minus 5. The second two terms, I am going to take out, let's see, I'm going to take out just a 1, okay? Because that's going to also leave that as 2x minus 5. All right, lastly, so I bring down that 2x squared again, keep bringing that down. Then I have x plus 1, and then I have 2x minus 5. So there's the numerator factored. So I'm going to go over here, make a blank fraction, and I'm going to write that numerator in there. So I've got 2x squared, I've got x plus 1, and then I've got 2x minus 5. There we go. Okay? All right, now let's do the denominator. So I've got 100 minus 16x squared. Well, I see that 116 are even, and I know that 4 actually goes into both of those. So I'm going to take a 4 out, and I'll get 25 minus 4x squared. Now I know, let me just backtrack a second here. because I do know that, let me just get my little pointer going here, that 116 are perfect squares, so technically this is dots, but since there's a common factor here, you want to take that common factor out first. Okay, it'll make life a little bit easier. We'll talk about that a little bit more tomorrow in class. So now I'm going to bring that 4 down, and now I'm going to do my dots, which is going to be 5 minus 2x and 5 plus 2x. Okay? All right, so let's rewrite that then. So I have 4 times 5 minus 2x and 5 plus 2x. There we go. So everything's factored, right? Okay. So now let's look and see what we have and see if we have any common terms that we can cancel rather. So, well, I see that I have a 2 and a 4 here, so that'll become a 1, and that'll become a 2. Now, let's talk a second about these guys. You see this and you see this? Those are opposites of each other. If you look, in the numerator, the 2 is a positive 2x. In the denominator, it's a negative. And the 5 in the numerator is a negative 5. And in the denominator, it's a positive 5. So those are opposites of each other. So what we can do is, let me see if I can write this down here. If I have 2x minus 5, I'm going to look at that factor in the numerator. If I multiply that by a negative 1, do you see that that gives me negative 2x plus 5? Okay, which is the same as 5 minus 2x. Okay, and then do you see that that, boop, 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 is the same as that? So what we can do, shortcut method, is if we see that we have two factors, like this 2x minus 5 right here, and this 5 minus 2x, if they're complete opposites of each other, we can cancel them out as long as we multiply one of the factors by a negative 1. So for example, I'm going to put the negative 1 up here in the numerator. I don't have to. If I really wanted to, what I can do is I could put the negative 1 down here. So it either has to go down here or it can go up here. It doesn't matter, whichever way you prefer. But because these are opposites of each other, you can cross them out, and you need a negative 1, either in the numerator or in the denominator. Whatever you do, not in both. Okay? All right, so then let's look and see what we have all the way across. So I've got a 1 times an x plus 1. And then I have that negative 1, so I'm going to just stick that right here. Okay, and in the denominator I have 2, and then I have 5 plus 2x. And there's our answer. All right, there's no need for you to distribute through or anything like that. That's it.